This is the reaction of trimethylamine with propanoic acid. First I'm going to draw the trimethylamine. So we have a nitrogen with 3 methyl groups around it. So this line is the bond and the end represents the CH3. And because it's an amine, it also has a lone pair of electrons. So we have 3 bonds to nitrogen, that makes it an amine, and a lone pair of electrons. We're going to be reacting this with propanoic acid. So we have 1, 2, 3 carbons and our carboxylic acid functionality. This looks similar to an amide formation reaction. However, in an amide formation reaction, we have to be able to make water, in addition to having the nitrogen bonded to the carbonyl. Because this is a tertiary amine, which we can also represent by putting a little 3 degree for third degree amine, it is not going to form an amide. Because it cannot bond to the carbonyl without having a positive charge. All we're going to do is acid-base. So we have a carboxylic acid, we have a tertiary amine. The acid is an acid, amines are always bases. So what will happen is this H will end up attaching or bonding to this lone pair of electrons. So what we'll have is an N with the new H and its 3 methyl groups with a positive charge, plus the remnants of the carboxylic acid, and so this would be called trimethylammonium. And this is an example of an ammonium ion because there are 4 bonds to nitrogen and a positive charge. And this is our propanoate ion. And generally speaking, this is an example of an ammonium carboxylate reaction, or an ammonium carboxylate salt being formed. Because this is our ammonium ion, this is our carboxylate anion. So if we react a tertiary amine with a carboxylic acid, we're only going to do acid-base reaction. We'll form the ammonium version of the amine and a carboxylate anion.